So let's start with DBMS Unit 1 Introduction. By data, it means known facts that can be recorded and that have implicit meaning. A database is a collection of related data. For example, consider the names, telephone numbers, and addresses of the people you know. You may have recorded this data in an indexed address book, or you may have stored it on a diskette using a personal computer and software such as DBS for Microsoft Access or Excel. This is a collection of related data with an implicit meaning and hence is a database. Now let's see the database management system. A database management system (DBMS) is a collection of programs that enables user to create and maintain a database. The DBMS is hence a general purpose software system that facilitates the process of defining, constructing and manipulating databases for various applications. Defining a database involves specifying the data types, structures, and constraints for the data to be stored in the database. Constructing the database is the process of storing the data itself on some storage medium that is controlled by the DBMS. Manipulating a database includes such functions as querying the database to retrieve specific data, updating the database to reflect changes in the mini world, and generating reports from the data. Now we will going to be see DBMS allows users the following task. Data definition. It is used for creation, modification, and removal of definition that defines the organization of data in the database. Data updation. It is used for the insertion, modification, and deletion of the actual data in the database. Data retrieval. It is used to retrieve the data from the database, which can be used by applications for various purposes. User administration. It is used for registering and monitoring users, maintaining data integrity, enforcing data security, dealing with concurrency control, monitoring performance, and recovering information corrupted by unexpected failure. Database systems versus file systems. One way to keep information on computer is to store it in operating system files. To allow users to manipulate the information, the system has a number of application programs that manipulate the files. Keeping organizational information in a file processing system has a number of major disadvantages like data redundancy, inconsistency, difficulty in accessing data, atomicity problems, security problems, and many more. Which takes us to the point of need of DBMS. DBMS is useful in the following ways. First, ease of accessing data. In the file system, different files are created for each user, creating data they can access. Also, in the file system, for the user to extract data, there is a need of code or application. Users can get easy access to data and can also specify the type of data they want to extract. Storage and management of data. Data can't be stored in the form of objects in the file system. The data in the practical world is generally stored in the form of objects and not files. So, an application is required to map the data into objects for further usage. In DBMS, the data can be directly stored in the form of objects. Third one, easy and efficient file management. In the file system, the entire database runs for every query operation as files are indexed. It takes a lot of time compared to DBMS, where objects are indexed based on the attribute of data. The complex management of memory becomes easy to handle. With this, retrieval of data is faster than traditional file system, avoiding duplicates and redundancy. Data normalization is used in DBMS to avoid duplicate data. Fifth one, concurrent data accessing. Users can access data simultaneously through different applications in the file system. This simultaneous access leads to inconsistency. DBMS uses the ACID approach to tackle the issue. Now let's see about the ACID. Here in the ACID, A stands for atomicity, C stands for consistency, I stands for isolation, D stands for durability. Now we will see the advantages of DBMS. Control database redundancy. It can control data redundancy because it stores all the data in one single database file, and that recorded data is placed in the database. Data sharing. In DBMS, the authorized users of an organization can share the data among multiple users. Easily maintenance. It can be easily maintainable due to the centralized nature of the database system. Reduce time. It reduces in development time and maintenance need. It provides backup for recovery subsystem, which create automatic backup of data from hardware and software failures and restores the data if required. Multiple user interface. It provides different types of user interface like graphic user interface GUI, application program interfaces, etc. Now let's see the data abstraction. For the system to be usable, it must retrieve data efficiently. The need of efficiency has led designers to use complex data structures to represent data in the database. Here are three levels: physical level, logical level, and view level. So, uh, physical level, the lowest level of abstraction describes how the data is actually stored. The second one is logical level. It describes what data is stored in the database. And the third and the last level is view level, which has the highest level of abstraction, describes only part of the entire database. The view level of abstraction exists to simplify users interaction with the system. The system may provide many views for the same database. There are three type of architecture in DBMS: one tier architecture, two tier architecture, and three tier architecture. One tier architecture is directly available to user. The user can directly sit on the DBMS and use it. That is the client, server, and the database all present on the same machine. Now let's see the two tier architecture. The two tier architecture is similar to a basic client server model. The application at the client end directly communicates with the database at the server end. Uh, APIs like ODBC, JDBC are used for the interaction. And now let's see the three-tier architecture. In this type, there is another layer between the client and the server. The client does not directly communicate with the server. Instead, it interacts with an application server, which further communicates with the database system, and then the query processing and transaction management takes place.